Mr. Sam's, have you ever eaten a lemon?
I can't say that I have.
Why don't you try it?
I don't know if that's in my best interest.
Oh, but for science.
Why don't you do it?
Fine, if you're not going to be man enough, I will. Mr. Sam's, are you sure this is a good idea?
Absolutely.
For science. Oh. Now, a lemon is an example of an acid.
What is an acid?
Well, Mr. Sams, I'm glad you asked. An acid is a compound that associates into H plus hydrogen ions in a solution.
That's right, acids are sour, corrode metal, and have a pH less than 7.
Some other examples of household acids are ketchup, vinegar, alcohol, and other citrus fruits like lemons.
Did you know that citrus fruits are named after their acidic traits?
Yes, I did. Did you know, Mr. Sams, that you can find all the traits of acids and bases on the chart we passed out?
You just mentioned acids and bases. What's a base?
Well, Mr. Sams, bases are compounds that dissociate into OH minus hydroxide ions in a solution.
Of course, they're also brittle, denatured proteins, and have a pH greater than 7.
An example of a base is baking soda. Now, I ate a lemon earlier. Why don't you try a teaspoon of baking soda?
No thanks, I value my health way too much.
Here's a chart with some examples of acids and base formulas. As you can see, the acids have hydrogen while the bases have hydroxide. One of the ways you can identify acids is because acid compounds begin with hydrogen. For instance, nitrous acid is HNO2.
You can also identify bases if it ends with hydroxide, like sodium hydroxide. It is NaOH. And that's what makes it a base.
We talked about dissociation before. Dissociation is when compounds in solutions split into their component ions.
Strong acids and bases dissociate in solutions completely, while weak ones only dissociate partially.
Dissociation, sort of like crime. It follows a breakup and results in water and salt components.
In the next video, we will talk about combining acids and bases in a process called neutralization.
In conclusion, do your homework and stay away from lemons.
Mr. Sims, you look different.
Oh, you need my glasses?
Ah, that must be it. Have you ever seen a baking soda vinegar volcano?
Oh, you mean like Pompeii?
No, like the ones that you would do in 4th grade science.
Oh, yeah, I do. When you add the baking soda to the vinegar, there's a huge eruption. Why does that happen again?
It's because of what are called acid-base reactions, also known as neutralization reactions.
In these reactions, the acid and base neutralize each other and produce water and salt.
Now we're going to show you a reaction between acetic acid and sodium bicarbonate.
The reactants are chemical components of baking soda and vinegar.
Acid-base reactions involve, you guessed it, an acid and a base.
Really? I didn't know that.
I'm sure you didn't, Mr. Sams. Anyway, here we have an example of a neutralization reaction.
The reactants in this equation are HCl, an acid, and NaOH, a base. All neutralization reactions produce water, H2O, and a salt in this case, which is NaCl.
Now, Mr. Sams, we have to write the net ionic equation.
This is easy for a neutralization reaction because it always has water for a product.
So we have H plus and OH minus. These are both aqueous. They combine into H2O, which is a liquid, and we're finished.
This is the general equation for an acid-base reaction. You have the hydrogen attached to an unknown anion, plus the Y, which is a cation attached to the hydroxide. Then it results in water with the cation and the anion combined together to create a salt. Then you have an unknown cation attached to the OH, the hydro oxide. Restart.
A lemon is an example of an acid.
What's an acid?
Well, Mr. Sams, an acid is a compound that dissociates into H+, that's hydrogen, and another ion in the solution.
Nathan, you just